So we've got some work done on this. Was gravel brought in by my lovely wife from our backyard, and I'm here playing with gravel. Okay, the gravel pieces of rock ground up and used as landscaping in our community. Everybody's house was built on this rock that we're grinding up here, and there's red ones that are just like this all over the place, and they're everywhere. They're AUPT. This is the gold-rich end member. It's metal. It's not minerals at all. It's a metal. The whole thing, not just a little bit of it. The whole darn thing, metal. This one is going to be beautiful. I'm going to polish this one up next. But I worked on this one. I've got it stuck to my magnet. These are magnets, and that's pure mid-range AUPT. It's half gold and half platinum. And I polished it up so that you could see what it looks like. This just came off of the ground like this. I smoothed it off a little bit more, and I've been working on it. It's very, very hard. It's like polishing stainless steel. And it's also, if you'll pardon my saying so, very, very beautiful. I think, anyway. And this stuff here, this is the AUPT, the black gold, is what I'm looking at it as, because it's this dark color, because it absorbs light and reflects it too at the same time. Look at that. And this was yard gravel here in Estrella Mountain Ranch where I live. And I know y'all think I'm crazy, pretty much, most of you. But here's the craziest thing that I've probably ever come up with. My gravel is not much different than your gravel. And see, I've been planning on replacing fiat currency, paper money, with real money, and wondering how I could distribute it evenly among us, so that everybody gets enough forever. And what I did was I wiggled my nose and I made every rock in your gravel into a piece of gold platinum alloy. Now, here's the problem. One of the reasons people don't recognize it as a metal is because they say, okay, it should conduct current. It should conduct current. And that's what this does. Checks to see how much resistance something has by running a little current through the metal. And so I can touch it, and it tells me if I have a complete circuit or how much resistance something has. And so, boy, let's see if we can get this thing to, hold on. Okay, so I'm holding this. I've got one thing up against there, the other thing up against the other side, and they are both touching, but they are not touching each other. And there's no circuit reading. And it doesn't matter what I do. It doesn't matter how smooth I make it, how much I polish it. This metal doesn't conduct electricity. And I haven't figured that out. It's because it has covalent bonding rather than metallic bonding, I think. I don't know. It is also, I believe, a room temperature superconductor. Okay? And that means that when I hit that current going through there, it should just pass right through with no resistance whatsoever. And instead, I'm getting a reading of infinite resistance or zero on my machine. I think that's why. It just, see, when I can hold this in my hand, it's metallic. Okay, so if I take a piece of metal and heat it up with friction or with a flame, it's the same thing. Okay, the atoms inside the metal start moving faster and faster and faster. And what happens when this heats up, this metal? I touch it and I burn myself. Right? It doesn't take but a second to heat that metal up and make it hot enough to burn me. And I could do it with my little red Zuper here, real fast. I turn it on and start working on a piece of metal, and it takes about 2 seconds for it to get too hot to hold. Okay. Wherever that damn rock went, I hold it in my hand while I'm polishing it, and it doesn't get hot at all. Now, I've been doing that with diamonds. Diamonds are dense, so that The atoms in the crystal lattice of a diamond are held together with a double covalent bond. And that allows them to share the 4 outer electrons in the carbon atom's outer valence orbit with each other. So a diamond is it becomes a superconductor for heat, and that is in fact how we test for them with those little machines that everybody goes around sticking on diamonds and thinking that they can tell a diamond from something that's not a diamond. Even though they don't really understand how that machine works. And so a big diamond, what they look for is little diamonds, okay? A little tiny diamond from De Beers. 1, maybe 2 carats at the most, right? They're just little tiny things. They're not like my diamonds, and that's, you stick that machine on there on one of my diamonds, and it doesn't act the same as the little tiny ones, because it takes more heat to get it to heat up, huh? Right? Or something. And so the way that I overcome that particular conundrum is by licking the stone. I lick rocks because I'm a geologist, and all geologists lick rocks. It's one of the tests for graduate students. If you don't lick rocks, you're not a real geologist. Okay, and so I lick rocks, and that thin coating of moisture, it's not like a puddle of spit, it's a thin coating of moisture, helps that little machine get a correct reading. Okay, bun it on there, and by spreading the amount of heat going onto it, it makes that machine give accurate readings on all stones, no matter what size they are. And so because with science you don't want more than one variable, so I lick all stones, and that way I get accurate information. But if you don't lick that sucker, you don't get accurate information, because it's looking for a superconductor of heat. Now, if I had a functioning one of those little diamond testers, and I don't, I could put it on this and it would read diamond, because I can hit that with my super and hold it in my hand. And it doesn't get hot. It never gets hot. It's a piece of metal. You can see that. It's a piece of metal. And it doesn't get hot. And the other day, I had a magnet on the end of a key ring so that it could dangle, and it kind of like what I was just doing, was checking the magnetism of one of these things, and I had two magnets, and it was floating between them. I had it on a key ring, and it was attracted to one and attracted to the other, and it then creates a force that repels both applied magnetic fields at the same time, and it floats. Because it's a superconductor. It's a room temperature superconductor.